Hi, everybody. Welcome you back for the electrical vehicle class. So today we are going to discuss about the configuration of electric vehicle. I have shared you the screen. Hope everybody just you can see. So today our topic is about the architecture of electric vehicles. As a recap, we will see what we have seen in the previous few videos. We have discussed about the evaluation of EV. What is the history of EV? What are the advantages and disadvantages of using an EV? And also, what are the basic components and what are the classifications and types of EVs? In this video, we'll be discussing about the architecture of electric vehicles and what are the various classifications or configurations of electric vehicle. With this small introduction, we'll just move into the video. This diagram shows the electrical vehicle configuration subsystem. What is there inside an electric vehicle? So the various blocks inside the electric vehicle consist of the supply wheel. From the supply point of brake or accelerometer, it is getting converted through the electrical propulsion system. What does the electrical propulsion system consist of? It consists of an electronic controller, power converter, electric motor, which is in turn given to the mechanical transmission system, and you have the wheels. So this consists of the electrical propulsion subsystem. With the electrical propulsion subsystem, you will have two types of subsystems. One is energy source subsystem, and second one is the auxiliary subsystem. In the energy source subsystem, you will have the energy management unit, energy source, energy refueling unit, which is supplied by the energy source. Second one, from the steering wheel, you get the input. So that input is given into the power steering unit, auxiliary power supply, temperature control unit. Okay, so this forms the complete electric vehicle configuration subsystem. So what happens inside this? When you just apply the brake or the accelerometer, the input signal is given to the electric controller. Electronic controller converts it into an electronic signals and give it to a power converter, which converts the form of output to the input to the electric motor, which in turn converts the controls the mechanical transmission, and it controls the wheel. So other two subsystems is the energy source, energy management system, and the auxiliary power systems. So this forms the basic block of an electric vehicle. The various configurations of electric vehicles are as follows. One is series hybrid, second one is parallel hybrid, third one is series parallel hybrid, and fourth one, a complex hybrid system. What is the series subsystem? So series hybrid consists of, you can see the block diagram of a series hybrid system. It consists of a fuel tank. It consists of an engine. Since it is a hybrid vehicle, so you need a fuel tank and a battery. So you have a fuel tank, engine, which gives output to the generator. From the generator, you can give it to a rectifier, a motor controller, a DC to DC converter, a battery charger, traction motor, and the mechanical transmission. The final input will be from the mechanical transmission. So two sources is given to the motor controller. One is from fuel tank, engine, generator, rectifier, and the motor controller. Two is battery charger, battery, DC to DC converter to the motor controller. And then it is given to the traction motor and the mechanical transmission system. So this series hybrid structure has several advantages and limitations too. What are the advantages? So one is the efficient and optimized power plant. Second one is the possibilities for modular power plant. Third one is the optimized drive line. Fourth one, possibility of swift black box service exchange. Fifth one is long lifetime. Sixth one is mature technology. Next is fast response and capable of attaining zero emission. And what are the limitations? Large traction drive systems is required. Requirement of proper algorithms, multiple energy conversion steps. Next comes the parallel hybrid system. What is a parallel hybrid system? It consists of a fuel tank, engine, mechanical coupling, mechanical transmission, final drive. And also, since it is a hybrid system, you need a battery charger, a battery controller, traction motor, and a mechanical coupling connected to the mechanical transmission and final drive for the differential output. So what is the difference between the first case and second case? You can see there it is a series connection. Here both are parallelly connected. So this have several advantages compared to the series. One is it's capable of attaining zero emission. It has an economic gain and more flexibility compared to the series system. But some limitations also there in the parallel hybrid system, which is expensive since both are connected parallelly. A complex control mechanism is required for both the things separately. Requirement of proper algorithms for switching over, need of high voltage to ensure the efficiency. Because of these advantages and disadvantages in the first two cases, there comes the combined series parallel hybrid architecture. What is a series parallel hybrid architecture? It consists of an engine, planetary gear unit, a generator, a motor controller, a traction motor, motor controller with a battery. So you can have a combination of both the cases. See, you can have a planetary gearing unit, which is given as an input to the motor, and from the battery, you can give it an input to the motor controller to the directly to the generator. So in this, you have second case, it's a drivetrain of series parallel hybrid system using a trans motor. So here you can see from the battery, you are giving to a motor controller and you have a lock mechanism where you can get to the input from the engine or transmission. Then there comes the motor controller and the traction motor. You can see the arrow mark, which from the battery, you can directly give it to the motor controller, then the traction motor and the lock. So both two motor controller is there. One is a motor controller and second one is a traction motor. So you can control by two different mechanisms. So this is one of the advantages of series parallel hybrid system. And last one comes the complex hybrid system, where you have the engine, power split device. One directly goes to the final drive vehicle's wheels. Second one is an electric motor generator, electrical energy storage system. From there, it supplies the electrical motor generator. Then it gives to the final drive to the vehicles on wheels, and then it is output is given. So this is the input split E CVT system. And second one is a compound split ECVT system, which has an engine. Both are mostly similar. This is an input type, and this is the compound of both. You have a power split device in front of final drive to vehicles, which can control the speed or control any other architecture of the total drive system. So this is a complex hybrid system. So with this, we have discussed today about the various about the configuration of block diagram of the electric vehicle subsystem. What are the four different configurations of e-vehicle? That is series parallel, and a complex subsystems. So in the next video, we will see in the next topic. Thank you. Bye.